Hello everyone. Today we are going to learn about how to draw an involute of a line. So here the question is given: draw involute of a line having length 10 mm for 5 turns. So we have to draw an involute of a line which have a length of 10 mm for 5 turns, that is 5 convolutions. One convolution means it is 360 degree. So we have to draw involute for a line for 5 turns. It is 5 into 360 degree. So 5 convolution means 5 into 360 degree. So first thing that we need to do is we have to draw a line having length 10 mm, that is 1 centimeter. So draw a line having length 10 mm. Let us say that the name of this line is AB. Now extend this line on both sides randomly or at random distance. Extend this line on both sides. Now take the rounder, measure the distance of B to A and give an arc like this. So let us say that this point is B1. Now change the center at A, measure the distance from A to B1 and give an arc. So this is A1. So this is half turn, that is 180 degree, and full turn, that is 360 degree. So now right now we have completed one convolution. We have to follow this method for 5 turns. Now change the center and put the rounder at B. That means take the center at B, measure B to A1, give an arc. So mark B1. Now change the center and put take the center at A, measure A to B1, give an arc. So now we have completed 2 turns. This is A2. Now change the center, take the center at B, measure B to A2, give an arc. Say this point as B2. Change the center at A, measure A to B2, and give an arc. So now we have completed 3 turns or 3 convolutions. A3. Now measure B to A3, give an arc. So this point is B4. Here we have made the mistake. This is B1, this is B2, and this is B3. Now change the center, take the center at A, measure A to B4, give an arc. This is A4. Now we have completed 4 turns, 4 convolutions. Now change the center, take the center at B, measure B to A4, B to A4, give an arc. 4.5 convolutions. This is B5. Now change the center, take the center at A, measure A to B5 and give an arc. to complete the 5 convolution of the involute of a line. So these are 5 convolution of involute of a line. Let us, if we want to measure the radiuses, this is R1, R2, R3, R4, R5, R6, R7, R8, R9 and R10. So these are the radiuses. First is R1, R2, R3, R4, R5, R6, R7, R8, R9, R10. So we can say that R1 is equal to 10, R2 is equal to 20 mm radius, R3 is equal to 30, R4 is equal to 40 mm, R5 is equal to 50 mm radius, R6 is equal to 60 mm radius, R7 is equal to 70 mm radius, R8 is equal to 80 mm radius, R9 is equal to 90 mm, and R10 is equal to 100 mm radius. So R1 is 10 mm. As we know that we have measured B to A 10 mm, then A to B1 R2, B to A1 R3, which is 30 mm. So we can measure the radiuses like this: R1, R2, R3, R4, R5. So this is the involute of a line. Now let us draw one another example or one another involute. Involute of a square having side line 30 mm. So first of all we have to draw a square having side length 30 mm. So first of all draw the square having side length 30 mm. So draw the square. Then after, let us discuss the definition of the involute. What is the definition of the involute? So for that I have taken a string. So if a string is wound around a plane surface, that is a square. Now right now we have taken the plane surface as a square. If a string is wound around a square or unwound from a square, if a string is wound around a plane surface, by keeping it tight, we have to keep the string tight. So by keeping it tight, then the curve traced out by any point or the locus generated by any point of the string is an involute. What is the definition? If a string is wound around a square, right now we have taken the plane as a square. So if a string is wound around a square, by keeping it tight, then the locus generated by any point on the string is an involute. So we have to wind a string around a square like this. So if we want to wind a string completely around the square, that means the string has to be completed or completely wound around the square. Then what will be the string length? So the string length will be equal to 4 into L. So first of all, extend this line. Let us give the name of this square. This is 0, 1, 2, 3. So extend the line 3, 0. Extend the line 3, 0 at random distance. Now measure the string length. Now for the square, or if you want to draw the involute of the square, the string length will be equal to 4 into side length of the square, 4 into L, that is L is the side length of the square. So now we have to measure 4 into L for here. So 4 into L, 4 into 30 mm. So the string length will be equal to 120 mm. So measure 120 mm. That will be the string length. Mm. Mark here P0. Now extend this line 0 1 1 2 2 3 at random distance. Now first of all measure 0 to P0, that is our string length. It is equal to 120 mm. It is equal to 4 into L. Give an arc. So as the winding of the string reach over here, now the string length will be wound around the square like this. So now the 30 mm length of the string is wounded on the side length of the square. So now the remaining length is 75 mm. It is 3 into L. Now the second thing that we need to change is the center. Now put your rounder at 1. Measure 1 to P1. Give an arc. This is P2. Now measure 2 to P2. Give an arc on this line. This is P3. Now measure 3 to P3 and give an arc. The arc will complete it at 0 because we have taken the string length is equal to 4 into L. So now what will be this length? 1 to P1, it is 3 into L. It is 75 mm. This 2 to P2 distance will be equal to 2 into L, and this 3 to P3 distance will be L. Now let us draw a normal and tangent to the involute. So if you want to draw the normal and tangent at any point on the curve, first of all mark that point. Let us mark that point over here as. Now here the arc generated is the arc of the circle, and the center of this arc is as 0. So if we connect this point to 0, and 0 is the center of this arc, so if we connect S point to 0, then this will be the normal to the curve. And now if you want to draw the tangent and draw a line perpendicular to the normal from point S, this line will be the tangent. So this is the normal, this is the tangent. A line perpendicular to the normal from point S is a tangent. So this is it for today. Thank you.